Welcome back to Dr. Fogg's TV.
Good day everyone, I remain your humble Dr. Fox. So today we are looking at chemistry, the topic isotopy. Chemistry, the topic isotopy. What is isotopy? Is the existence of an element with the same atomic number but different mass number. That is isotopy. Existence of an element with the same atomic number but different mass number. Why isotopes are elements with the same atomic number but different mass number. So we have a lot of elements that are isotopic in nature. Example, I have hydrogen 1,1, I have hydrogen 2,1, I have hydrogen 3,1, I have boron 9,5, I have boron 10,5, oxygen 15,8, oxygen 16,8, oxygen 17,8, oxygen 18,8. The sodium 23,11, sodium 22,11. You have a lot. Now if you check it now, they all have the same atomic number, different mass number. Same atomic number, different mass number. Same atomic number, different mass number. Now the ones for the hydrogen, they have special names. Hydrogen 1,1 is called protium, 2,1 is called deuterium, also called heavy water. 3,1 is called tritium, and the 3,1 is the radioactive part of isotope of hydrogen. So having said this, we have 5 questions to solve on isotopes. Don't forget the same atomic number with different mass. Question 1. Natural lithium consists of 2 isotopes. I have 7.4% of lithium 6 and 92.6% of lithium 7. Determine the relative atomic mass of natural lithium. Relative atomic mass of natural lithium. Now how do you calculate this? It's simply relative atomic mass is 7.4 divided by 100 times 6 plus 92.6 divided by 100 times 7. So how do you calculate this? It is what? Respective is the percentage, because whenever percent is divided by what? 100, then multiplied by the respective mass numbers, and we are adding 7.4 divided by 100 times 6, then 92.6 divided by 100 times 7. So my RAM becomes 7.4 multiplied by 6, that is 44.4 over 100 plus 92.6 multiplied by 7, that is 648.2 divided by 100. So my RAM, since I have the same denominator, I don't need to find my LCM. So I just have 44.4 plus 648.2. That is 692.6 divided by 100. So my RAM becomes 6.93. So I approximated this. That is question 1. So we move to question 2. It says an element Q has isotopes. I have Q 6329 and Q 6529 in the abundance of 70% and 30% respectively. This is 70% and this is 30%. Then calculate the relative atomic mass of what? Of element Q. So RAM, don't forget, is the respective percent over 100, that is 70 divided by 100, multiplied by the mass number, which is what? 63, plus 30 divided by 100 multiplied by 65. So my RAM Here I can say is 0 cancel 0. So 7 multiplied by 63, that is 441 divided by 10. Plus here also 0 cancel 0. 3 multiplied by 65 is 195 divided by 10. So my RAM becomes 441 plus 195. That is 636 divided by 10. So my RAM becomes 63.6. That is question 2. So you have solved 1 and 2. We move to question 3. So question 3, they said if a sample of an element Q exists in 1:2:3, calculate the relative atomic masses of each isotope of Q, given that the relative atomic mass of Q is 1.1. Now this time around, we have our RAM, but we are looking for the what? Atomic masses of individual elements there. Now, because there are 3, 1:2:3, the first thing is my total ratio is equals to 1 plus 2 plus 3, that is 6. Now, for each of them, to get the ratio of 1, so to get the ratio of 1, it becomes what? 1/6 multiplied by what? RMM, 1.1. So here becomes 1.1 divided by 6. That's 0.18. For 2, I have 2 divided by 6 multiplied by 1.1. 2 here is 1, 2 here 3. That is 1.1 divided by 3. That is 0.36. So moving, for 3, that is 3 divided by 6 multiplied by 1.1. 3 here 1, 3 here 2. That is 1.1 divided by 2. That is 0.55. So this are the what? Individual relative atomic masses in respect of 1:2:3. Then I move to number 4. Number 4 says chlorine is composed of 2 naturally occurring isotopes, which are chlorine 37 and chlorine 35. If the relative atomic mass of chlorine is 35.5, determine the percentage abundance of each isotope in a naturally occurring chlorine. Now, we're looking for the percentage abundance. Don't forget, there is a percentage divided by 100 multiplied by the what? Mass, relative atomic what? Mass, and by the mass number. So here, I'll say let the individual abundance of chlorine 37 equals to what? X. That is X percent. So if here is X divided by 100 times 37 plus, now if here is X, this place will be 100 minus what? X. Because percentage is over 100. Let's assume that here is 60, here will be what? 40. How do you get 40? That will be what? 100 minus what? 60. Now if you check question 1, if you add your percent, it must equal to what? 100. Question 2, when you add is what? 100. So if here is X, that means here will be what? 100 minus what? X. To get the other percent, then divided by 100 multiplied by what? 35 equals to my RAM, which is what? 35.5. So here becomes what? 37x divided by 100 plus, let me have this in brackets, 35 times 100, that is 35. 35 times minus x, minus 35x divided by 100 equals 25.5. So if I add up this is 37 minus 35, because there is plus times minus is minus. So here is what? 37 minus 35. Okay. Here is 2x plus 35 divided by 100 equals 35.5. So coming here, it becomes 2x plus 35 equals to 35.5 multiplied by 100. So here is 2x plus 35 equals to 3,550. Then I collect my like terms. 2x becomes 3,550 minus 35. So here it becomes what? 50. Divided by 2, divided by 2. This cancel this cancel this. My x is what? 25. If x is 25, therefore 100 minus x equals to 100 minus 25. That will what? 75. So the first one is 75%, second one is 25%. So that is number 3 and number 4. So very quickly we move to number 5. An element Q naturally is composed of 3 isotopes. I have Q95, Q96 and Q97. Contributed to here is 27%, 45% and X%. So the natural isotopes of Q. Calculate the value of Q if the RAM is 96.2. Now, I want to solve this. Here is 95, 96, 97. And their abundance are in 27%, 45% and X%. Now I'm going to solve it. After solving, then I will confirm if I add these ones and I subtract from 100, then will give me this. Because we said earlier that percentage is over what? 100. Now since I have 2%, if I add these two and subtract from 100, then I should get this. But let's solve. So here is 27 divided by 100 times 95 plus 45 divided by 100 times 96 plus x divided by 100 times 97 equals to 96.2. So 27 multiplied by 95, 2,565 divided by 100 plus 45 multiplied by 96, that is 4,320 divided by 100 plus 97x divided by 100 equals 96.2. Now I'm adding this. Here is 2,565 plus 4,320. That will give me 6,895 plus 97x, then everything over 100 equals 96.2. I will cross multiply 6,895 plus 97x equals 96.2 multiplied by 100. So here becomes 6,885 plus 97x equals to 9,620. So if I collect like terms, it becomes 9,620 minus 6,885 equals to 97x. So 9,620 minus 6,885, that is 2,735 equals 97x. So if I divide by 97, so my x becomes what? 28.1%. So if I possibly the nearest whole number, that is 28%. It's confirmed. Which means that when I add these two, subtract from 100, I will also get what? 28. So that is the end of today's class. Isotopes. Elements with the same atomic number but different mass number. So make sure you view, like and subscribe to my YouTube channel.